Hi everyone, welcome to this new video and welcome to this channel. Today I'm going to start a series of videos about model tuning using MLflow and Hyperopt. I already have a playlist about MLflow, so if you want to get familiar with MLflow, you can check the link in the description box of this video. During the next videos, we are going to be talking mostly about Hyperopt and model tuning. So since this is the first video, I'm going to start by defining some fundamental concepts. And the first one is, what is model tuning? Well, model tuning is the process of finding the hyperparameters that optimize the model performance or the performance of the model, right? And unlike parameters, hyperparameters cannot be learned from the training data. Instead, they control the training process. For that reason, we have to choose the hyperparameters before the training process begins. Now, there are plenty of tools and algorithms that we can use to do this hyperparameter optimization. However, for the next videos, we are going to be talking about Hyperopt. What is Hyperopt? Well, Hyperopt is a Python library for serial and parallel hyperparameter optimization, and it uses Bayesian reasoning to find the best hyperparameters. I'm not going to dive into the algorithm, but we are going to be exploring the library and how to use it for this hyperparameter optimization process. Now, what are the steps involved in this process? First, we have to describe the search space. What is the search space? Well, the search space is the space in which we believe or we think that the best hyperparameters can be found. For that reason, it's very important the domain knowledge because depending on the type of problem that you are trying to solve and the type of algorithm or model, machine learning model that you're using, this search space might be different. Then we had to define an objective function. This is usually a loss function because in the next step we are going to optimize the function by finding the minimum. So for that reason, it's very important to define this objective function as a loss function. Then we have analyze the trials, and the trials are basically the iterations of this algorithm. Sometimes it's very important to know what is happening in each iteration. So let me show you a graphical representation of what I am saying. So here we have this figure. Let's assume that this is a loss function given for this equation that we can see here. When we are talking about hyperparameter optimization with Hyperopt, what we are saying is that we have to find the minimum of a loss function like this. Of course, in this case, we have only two hyperparameters, x and y, but in a real machine learning scenario, we might be dealing with a lot of hyperparameters. So it's a high dimensional space. So in this case, it's very easy to find the minimum. The minimum value that this function can take is 2, right? There is nothing below 2. Um, and that happens when y is minus 1, right? We can see here, minus 1. And, oh no, let me just move this point again. This was minus 2 and minus 2. Okay, so this is the minimum, right? Is 2, and it happens when x is 0 and when y is minus 1. So let's try to find this minimum using Hyperopt. Let me share with you the code that I have prepared for this video. So here we are. The first step is to define the objective function, and that's very simple because we just had to write the equation that I showed you before. Then we had to define the search space. Now the search space is defined like this, and it's basically this square that I am defining here, right? The square defined by the points A, B, C, and D. Now, this is very important because let's say that someone wants to explore this region. Let's say that someone decides to define the search space in this region. Well, we are not going to find the minimum of this function, never, right? So, but since I have the domain knowledge about this function, I can say, hey, I believe that the minimum value can be found between these points. So that's why it's very important to define the definition of the search space. Okay, and then we have trials, and then we're using fmin, right? This is a function that we're going to be using to minimize the objective function. Now fmin takes the objective function, the search space, the algorithm in this case is TPE, and TPE stands for three parse estimators. It's an algorithm that uses Bayesian reasoning to find the best hyperparameters, the maximum evaluations, or maximum number of iterations, and trials. Let's run this code and get the best value. Okay, as we can see here, we have 0.00, that's basically 0, and y is minus 0.99, that's basically minus 1. So let's try to explore every iteration by plotting those points. I'm going to use this code that I have prepared here. I have this function called getCoordinates, and it takes trials object as a parameter. Um, I'm basically taking the loss, the x, and the y value for each iteration. So I'm going to copy this code so we can plot that iteration process. Okay, now I'm going to get this. And now instead of printing the best values, I'm just going to plot every iteration, right? Because here I am iterating over the trials. And for each iteration, I am getting the loss, the y value and the x value. So let's plot this and see what happens. Okay, so here we are. Okay, let me just share this. Okay, here. This is the plot, right? It's actually the dimensional scatter plot. And we can say that the points, are all kind of, let's say, following the shape of the function, the loss function. And we can see that most of the iterations are, close to the minimum point, which is 0 for x and minus 1 for y, right? Let's try with more iterations. Let's say that I want to try with 2000, just to make more evident that the algorithm is getting closer and closer to the minimum value, or to the point in which the loss function reaches its minimum. Okay, it's taking a while. Fortunately, this is a very simple function, so it's something achievable using my local machine. Okay, now let's see the plot. This is the plot. Now it's more evident that the Hyperopt is finding this point as the base point for this function, for this loss function. And as we can see here, is 0 for x and minus 1 for y. And which value is reaching? Well, 2. As you can see here, we can see 2, right? Is basically 2. So that was basically for this, everything for this video. In the next video, we're going to explore more the capabilities that the Hyperopt has to define search spaces. Thanks for watching this video, and I'll see you in the next one.